Venn diagrams for 3 sets introduction. So we've already spent some time learning about Venn diagrams with 2 sets and how they help us visualize the relationships between those sets. Things that are common, things that are unique, and so on. Now, on this slide, we're going to take that knowledge and build upon it. This section will extend our understanding to include 3 sets. Now, working with 3 sets might seem a little more complicated at first, and you're right, the diagram is a bit more complex than the 2-set version. But don't worry, the underlying principles are exactly the same. We're still dealing with sets, intersections, and unions, just with one more set thrown into the mix. Over the next few slides, we'll carefully explore how to actually draw these 3-set Venn diagrams correctly. We'll make sure each circle overlaps appropriately to show all the possible relationships. And importantly, we'll also learn how to interpret the different regions within the diagram. Understanding what each section represents is key to using Venn diagrams effectively. So, let's get started with building these diagrams. So we've already spent some time learning about Venn diagrams with 2 sets and how they help us visualize the relationships between those sets. Things that are common, things that are unique, and so on. Understanding the diagram. Now, looking at this slide, the first key point is that a Venn diagram for 3 sets utilizes 3 overlapping circles. Each of these circles visually represents a different set. Think of each circle as containing all the elements that belong to a specific group, set A, set B, and set C, as we'll label them shortly. Next, and this is really important, these 3 circles are all drawn inside a rectangle. This rectangle isn't just there for decoration. It represents what we call the universal set. We can think of the universal set as encompassing absolutely everything we're considering in this particular problem. It's the complete collection of all possible elements. Finally, and you've probably seen this before with 2-set diagrams, the areas where the circles overlap are crucial. These overlapping regions represent the intersections of the sets. What that means is, those areas contain the elements that are members of more than one set. For example, where circle A and circle B overlap, you'll find the elements that are in both set A and set B. So let's take a closer look at how a Venn diagram for 3 sets is actually structured. As we discussed on the previous slide, extending from 2 sets to 3 sets just adds a bit more complexity to the diagram, but the underlying principles remain the same. We'll be diving deeper into identifying all these different regions in the following slides, and we'll even work through an example to see how it all comes together. But for now, make sure you understand this basic structure. 3 overlapping circles within a rectangle representing the universal set, with the overlaps showing the intersections. Drawing a 3-set Venn diagram. So now that we've discussed what 3-set Venn diagrams are and how to understand them, remembering the universal set and those crucial overlapping regions, let's move on to actually drawing one. This is slide 3, and it's a step-by-step guide. First, and this is important to establish our boundaries, draw the universal set. Start by drawing a large rectangle. Think of this rectangle as encompassing everything we're considering in our problem. We call this the universal set, and mathematicians denote it with a capital U. Next, draw the circles. Inside that rectangle, we need to draw 3 circles. Now, here's the key. These circles must overlap each other. Each circle should intersect with the other 2. Imagine them kind of weaving in and out. The goal is to create distinct regions within the rectangle. We need to be able to clearly see where the circles overlap and where they don't. Don't just draw them randomly. Think about how the overlaps will divide the space. Then, label the sets. Once you have your circles drawn, label each one with the name of the set it represents. It's common to use letters for sets, so let's label them A, B, and C. This makes it much easier to refer to each set when we're analyzing the diagram. Finally, identify the regions. This is where it all comes together. Let's break down what each region means. The areas inside each circle represent all the elements that belong to that specific set. So everything within circle is part of set A, and so on. Where 2 circles overlap, that represents the elements that are in both of those sets. That's their intersection. The area where all 3 circles overlap represents the elements that are in sets A, B, and C simultaneously. And finally, the area outside all the circles, but still inside the rectangle, represents elements that don't belong to any of the sets A, B, or C. Keep these regions in mind, because on the next slide, we'll be looking at how to interpret them in detail and what they actually tell us about the sets. So, practice drawing this diagram a few times, making sure your circles overlap nicely and you can clearly identify all the different regions. Interpreting the regions. Let's start with A only. This refers to the portion of the circle representing set A that doesn't overlap with either set B or set C. So, this section holds all the elements that are in A, but are not in B and are not in C. Think of it as the unique members of set A. Next, we have B only. This is the same idea, but for set B it's the part of the B circle that doesn't overlap with A or C, meaning it contains elements that are exclusively in set B. And similarly, C only represents the portion of the C circle that doesn't overlap with A or B, elements unique to set C. Now let's move on to the overlapping regions. A intersection B, written as a cap B, represents the elements that are in both set A and set B. Remember the intersection means, and, however, crucially, this region excludes any elements that might also be in set C. A intersection C, or a cap C, is the area where the A and C circles overlap. This represents elements that are in both A and C, but not in B. And B intersection C, or B cap C, is the overlap between B and C, excluding any elements that are also in A. Now, for the very center of the diagram, a intersection B intersection C, or a cap B cap C. This is where all three circles overlap. This region contains the elements that are members of all three sets, A, B, and C. It's the common ground for all three. Finally, we have the area outside of all the circles, but still inside the rectangle. This is represented as U minus, a union B union C. Let's break that down. U represents the universal set, everything we're considering. The union of A, B, and C means all the elements that are in A or B or C or any combination of them. So, subtracting that from the universal set U leaves us with everything that is not in A, not in B, and not in C. This is called the complement. So now that we know how to draw a three-set Venn diagram, remember the rectangle for the universal set and the overlapping circles, let's really understand what each part of that diagram means. This slide breaks down all the different regions we've created. Understanding these regions is absolutely key. In the next slide, we'll put this into practice with an example, and you'll see how we actually fill these regions with elements. So, make sure you're comfortable with what each section represents before we move on. Example. So now we're going to put everything we've learned about three-set Venn diagrams into practice with a concrete example. As you remember from the previous slides, we've discussed how to draw the diagram and interpret all the different regions. Now, let's actually fill one in. First, let's define our sets. We have set A, which contains the numbers 1, 2, 3, and 4. Set B contains the numbers 3, 4, 5, and 6. And finally, set C contains the numbers 5, 6, 7, and 8. Now, let's start populating our Venn diagram. The first thing we need to determine is what, if anything, is in the intersection of all three sets. That is, what elements are common to A, B, and C. We represent this as an intersection B intersection C in this case. Looking at our sets, we see there are no common elements. Therefore, an intersection B intersection C is the empty set, which we denote by the symbol for the empty set. This means the very center of our Venn diagram, where all three circles overlap, will remain empty. Next, let's find the intersection of A and B. That is, the elements that are in both A and B. Looking at our sets, we see that the numbers 3 and 4 are in both. So, an intersection B is equal to the set containing 3 and 4. We'll place these numbers in the region where the circles representing A and B overlap, but importantly, not in the circle representing C, because they aren't in C. Now, let's consider the intersection of A and C. Are there any elements that are in both A and C? If we look at the sets, we see there are none. So, an intersection C is also the empty set. This means there's no overlap between the A and C circles. let's move on to the intersection of B and C. We see that the numbers 5 and 6 are present in both sets. Therefore, B intersection C is equal to the set containing 5 and 6. We'll place these numbers in the region where the B and C circles overlap, but again, not in the circle. Now, let's find the elements that are only in A, that is, the elements in A that are not in B or C. Looking at set A, we have 1, 2, 3, and 4. We've already placed 3 and 4 in the intersection B region, so that leaves us with 1 and 2. These are the elements that belong to A only, so we place them in the part of the circle that doesn't overlap with B or C. Next, let's find the elements that are only in B. Looking at set B, we have 3, 4, 5, and 6. We've already placed 3 and 4 in the intersection B region, and 5 and 6 in the B intersection C region. This means there are no elements left that are only in B, so B only is the empty set. Finally, let's find the elements that are only in C. Looking at set C, we have 5, 6, 7, and 8. We've already placed 5 and 6 in the B intersection C region, leaving us with 7 and 8. These are the elements that belong to C only, so we place them in the part of the C circle that doesn't overlap with A or B. And that's it. We've successfully populated the Venn diagram with all the elements from our 3 sets. Remember, this exercise is all about carefully identifying which elements belong in each region based on their set memberships. This will be very helpful as we move on to solving more complex problems using Venn diagrams. Key takeaways. Let's recap everything we've learned about 3-set Venn diagrams with these key takeaways. 3-set Venn diagrams visually represent the relationships between 3 different sets. Essentially, what we've been building towards is a clear picture of how 3 groups of things connect and differ. Remember, a picture is often worth 1,000 words, and this diagram helps us see those relationships. The overlapping regions represent the intersections of the sets. Now, you'll recall from our earlier discussions, the intersection of 2 sets means the elements they both have in common. In our 3-set diagram, wherever the circles overlap, that shows us what elements are shared between those specific sets. So, if we have sets A, B, and C, the area where all 3 circles meet represents the elements in A, B, and C. Understanding each region is crucial for interpreting the diagram and drawing accurate conclusions. This is really important. Don't just look at the whole diagram, break it down. Each section, whether it's just in one circle or where 2 or 3 circles overlap, tells us something specific about which elements belong where. Being able to correctly identify what each region represents is key to solving problems using these diagrams. We practiced this on the previous slide with our example sets. The universal set contains all elements under consideration, including those that do not belong to any of the sets. Finally, let's not forget the rectangle surrounding the circles. That represents the universal set. Think of it as everything we're talking about in a given problem. It includes everything inside the circles, the elements that do belong to at least one of our sets, but also everything outside the circles, which represents elements that don't belong to any of the sets we're specifically looking at. Now, on the next slide, we'll be looking at some common mistakes students make when working with these diagrams, so pay close attention to those to avoid falling into the same traps. But for now, make sure you feel comfortable with these core concepts. Do you have any questions about these key takeaways before we move on? Common mistakes. First, it says incorrectly identifying intersections. Now, remember from the previous slides, the intersections are those overlapping regions. Students sometimes get tripped up trying to figure out which sets are overlapping to determine the correct region. So, when you're looking at, say, the intersection of sets A and B, you need to carefully pinpoint the area where the circles representing A and B both overlap. Don't include any part of set C in that region unless it's overlapping with all 3. Take your time and visually confirm which sets define that specific intersection. Next, we have forgetting the universal set. This is a surprisingly common error. Remember that large rectangle we drew around the circles? That represents the universal set, everything we're considering in the problem. It's easy to get focused on just the circles themselves, but the rectangle is crucial. It reminds us that there might be elements that don't belong to any of our sets A, B, or C always included in your diagrams. Finally, misinterpreting the complement. The complement, which we represented as U minus the union of A, B, and C, is everything outside the circles but inside the rectangle. It represents the elements that are not in A and not in B and not in C. Students sometimes mistakenly include elements that are within the circles, or they forget to include the region outside the circles altogether. So, double-check that you've correctly identified the elements that don't belong to any of the sets. Let's move on to the final slide, which highlights some common mistakes students make when working with three-set Venn diagrams. It's good to be aware of these before you encounter them in practice, so you can avoid them. So, keep these 3 points in mind as you practice drawing and interpreting three-set Venn diagrams. By being aware of these common pitfalls, you'll be well on your way to mastering this important mathematical tool.